Good evening, dear students. Welcome back to the Engineering Mechanics lecture series. In the previous lecture, we have seen about engineering mechanics, definition of engineering mechanics, categorization of engineering mechanics, and basics of engineering mechanics. So today in this lecture, we will learn the next topics in engineering mechanics. So we will start with what is a force. Then we will go on to characteristics of a force and system of forces. So starting with what is a force. Force is nothing but it is an agent which tends to change the state of rest or uniform motion of a body. Once again I will repeat. Force is an agent which tends to change the state of rest or uniform motion of a body. So force has certain characteristics. What are those characteristics? Magnitude, direction, line of action. So these three are the important characteristics of a force. Let me explain with an example here. So I have represented a force and the number 30 Newton. So this represents the magnitude of a force. Magnitude is nothing but a certain number or quantity used to measure the force. So here the value 30 represents the magnitude of the force and the n is the Newton, represents the unit of the force. The direction is nothing but the theta equal to 30 degrees. So the force is acting at an angle of 30 degrees. Geometric representation of a force. Geometric representation of how a force is applied. That is called as line of action. Here, this represents the line of action of the force. So the characteristics of a force can be represented by three terms. One is magnitude, which is nothing but the quantity that is used to represent the force. That is magnitude. Direction is the angle with which the force acts. A line of action is nothing but the geometric representation of the force. Next we will go to the system of forces. When there are more than two forces acts on a body, then it constitutes a system of forces. When more than two or more forces acts on a body, it constitutes a system of forces. So here we have major classifications such as coplanar forces, non-coplanar forces, collinear forces, concurrent forces and parallel forces. When all the forces acts on a same plane, that is called as coplanar forces. When the force acts in different planes, then they are called as non-coplanar forces. So let me show it here. So here in this diagram, we can see there are three forces acting in the same plane. So this represents a coplanar force. When the forces are acting like this, so here the forces are acting in two different planes, so they constitute a non-coplanar force. Then collinear forces. When all the forces are acting along a same line, then they are called as collinear forces. So here you can see that these forces are acting on a same line. So this is called as collinear forces. So we have seen coplanar, non-coplanar and collinear. The next category is concurrent forces. When all the forces converge at a single point, then they are called as concurrent forces. So suppose this is a particle and there are three forces acting on the particle like this. So you can see that all the three forces converge on the particle. All the three forces converge on a particle at a particular point. So this constitutes a concurrent force system. Parallel forces. When the forces are acting parallel to each other like this, then these are called as parallel force system. So now we have seen about the system of forces. Coplanar forces are nothing but when the forces are acting in the same plane, they come under the category of coplanar forces. when the forces are acting in different planes, they constitute a non-coplanar force system. When all the forces act on the same line, then they are called as collinear forces. Then when the forces acting on a body or a particle converge at a single point, then they form a concurrent force system. When the forces are acting parallel to each other, then they constitute a parallel force system. Next we are going to see about resultant force. So what do you mean by resultant force? Now already we have seen in the system of forces, when more than two or more forces are acting on a body, they constitute a system of forces. Now resultant force is nothing but if all the forces acting on a body or a particle, if it can be replaced by a single force but the effect remains the same, then that force is called as a resultant force. If all the forces acting on a body or particle is replaced with that of a single force and the effect produced by that single force is equal to that of all the forces acting on a body, then that single force is called as a resultant force. Let me explain with the example here. Now here three forces are acting between A and B. Say 3 Newton force, 2 Newton force and 2 Newton force. So this constitutes a collinear force system because all the forces are acting along a single line. So this is a collinear force system. Now these three forces are replaced with a single force, that is 3 plus 2, 5 plus 2, 7 Newton. So now this is a single force which is used for replacing all the other three forces, and this single force which replaces all the three forces, but the effect produced by the single force is same as that of all the three forces, then this single force is called as the resultant force. Similarly, the force has a sign convention. Force is a vector quantity. As already we have seen, it has both magnitude and direction. So the force has certain sign convention. So we assume the following sign conventions, which are standard sign conventions followed in most of the textbooks. So we will also adopt the same. So here towards right, the force acting towards right is taken as positive and force acting towards left is taken as negative. Similarly, the force acting upwards is taken as positive and the force acting downwards is taken as negative. So this sign convention should be meticulously followed while solving the problems. So now we will see how to determine the resultant force. So the resultant of a force can be determined using two methods. One is the analytical method, another one is the graphical method. So now we are going to see how to determine the resultant force using an analytical method. So analytical method is based on the parallelogram law of forces. What is parallelogram law? If two forces acting on a body or a particle be represented in magnitude and direction by two adjacent sides of a parallelogram, then the diagonal of that parallelogram represents the resultant force originating from that point. So I will give the parallelogram law in the description. Now we will see how to determine the resultant of a force using parallelogram law of forces. Now I have taken two forces P and Q acting at an angle of theta. Now I am constructing a parallelogram using these two forces. So now these two forces have become the adjacent sides of a parallelogram, and we have completed a parallelogram O, B, C and A. O, B, C, A represents the parallelogram with P and Q forming the adjacent sides of a parallelogram. The angle between P and Q is theta. Now a triangle is constructed on this edge of the parallelogram, that is ACD is the triangle constructed on this edge of the parallelogram. Now we will see how to determine the resultant force using this parallelogram law of forces. Now based on the diagram represented here, I am explaining the procedure for finding the resultant in the above space. Now from the diagram, consider the triangle AC and D. Now you take cos theta. We all know that cos theta is equal to adjacent by hypotenuse. So the adjacent side is AD and hypotenuse side is AC. So AD by AC, which is equal to AD by AC is nothing but it is the adjacent side of a parallelogram. So for the parallelogram, the opposite sides are always equal. So this and this sides will be equal. So here you have AC as Q. So now AD is equal to Q cos theta. Similarly, you take sin theta. Sin theta is equal to opposite by hypotenuse. So opposite is nothing but CD. Hypotenuse is again AC. So CD by Q. So CD equal to Q sin theta. Now this can be verified. You apply the Pythagoras theorem for this right angle triangle. AC square equal to AD square plus CD square. So AD square is nothing but Q square cos square theta, because AD is equal to Q cos theta, and CD square is equal to Q sin theta. So Q square sin square theta. So if you take Q square as common here, you will get cos square theta plus sin square theta. You all know that cos square theta plus sin square theta is equal to 1. So AC is equal to Q. Bigger triangle OC and D. Now for this triangle we are applying the Pythagoras theorem. OC square equal to OD square plus CD square. OC square equal to OD square plus CD square. Now this OD can be written as OA plus AD. That's what I have written here. OD can be written as OA plus AD. So OA plus AD the whole square plus CD square. Now this can be expanded using the rule A plus B the whole square, which is nothing but A square plus B square plus 2AB. So OA square plus AD square plus 2 into OA into AD. So we have expanded this using the rule A plus B the whole square. Then the same term CD square is written here. Now already we know that OA is equal to P square. AD, already we have found AD equal to Q cos theta and CD equal to Q sin theta. This we have already determined. So applying here, AD is nothing but Q cos theta. So Q square cos square theta plus 2 into OA. What is OA? OA is P. So 2 into P into what is AD? AD is Q cos theta. So 2 into P into Q cos theta. Now what is CD? CD already we have found CD equal to Q sin theta. So we apply here Q square sin square theta. Now you got this as an equation. OC square equal to P square plus Q square cos square theta plus 2P into Q cos theta plus Q square sin square theta. This OC square equal to P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. Now combining these two terms together, we get OC is nothing but R. So R square equal to P square plus combining these two terms, we get Q square into cos square theta plus sin square theta plus 2PQ cos theta. Now we all know that cos square theta plus sin square theta is equal to 1. So this gets reduced as R square equal to P square plus Q square plus 2PQ cos theta. So now R is nothing but it is equal to square root of P square plus Q square plus 2PQ cos theta. So this equation gives the magnitude of the resultant force. This equation R is equal to square root of P square plus Q square plus 2PQ cos theta gives the magnitude of the resultant force. To find the direction of the resultant, you consider the triangle OC and D. Now the angle made by the resultant is alpha. We are going to find tan alpha. So tan alpha is nothing but opposite by adjacent. So what is the opposite side of the triangle? It is CD. What is the adjacent triangle side of the triangle? It is OD. So opposite by adjacent, so CD by OD. Now this OD can be written as OA plus AD. So CD divided by OA plus AD. Already we know that CD is equal to Q sin theta. OA is nothing but P and AD is nothing but Q cos theta. So now you substitute that here. So tan alpha is equal to Q sin theta divided by OA is P plus Q cos theta. From that we can find alpha. Alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. Already we have found the magnitude as R is equal to square root of P square plus Q square plus 2PQ cos theta. So these two equations helps us to determine the magnitude of the resultant force as well as the direction of the resultant force. I hope you have understood this particular equation and how to determine the equation using the parallelogram law of forces. So it's a very important topic in the unit number 1. So I request all of you to listen to this again and again and understand how this equation has been framed from the parallelogram law. For more interesting lectures in engineering mechanics, please do subscribe and share it. Thank you.